Ever get that feeling you've been set up a little bit? Right, good evening. Thank you very much for inviting me to speak. I'm thrilled to be here. I'm thrilled to be doing this back at Imperial. It was 42 years ago this September when I first arrived. As a 18-year-old from Cornwall, I'd only left the county 4 or 5 times, and London. So I thought the whole of London was like Kensington. Took me a while to figure that out, but it's lovely to be back, and I'm very pleased to talk about the project. So let's get straight to it and start with the reason why we're doing this. There's no sound on this, but it does get more involved in a second. So that is raw sewage, and that's an event that happens about 60 times a year at the moment throughout London. On an average year, about 40 million tonnes, cubic metres of untreated sewage spill into the river. The lead tunnel, which was built and commissioned a few years ago, was taking care of about 18 million of that. But that's 40 in an average year. About 3 years ago, it was over 70 million tonnes spilling into the river, and the reason why something needed to be done. I will touch on the whole suds point later. I think the part of the history of the project, there's some lessons to learn there about views and stances that people take. But nonetheless, let's have a look. So when we talk about the project, we have 2 stories to tell. Clearly the engineering one and the challenges of building a very large tunnel under the Thames and building very close to the river walls, which are inevitably not quite what you thought they might have been. And so that's an interesting story in its own right, and I'd like to talk about that. But I'd also like to talk about the other stories. So we have the engineering story, and we have what I like to refer to as a love affair. It's a story of romance and a relationship between the people of a city and the river. That's the main reason why the city was there in the first place. And a vision that we certainly have of wanting to repair what we see as a broken relationship. And I'd like to touch on that a little bit more as we go along. So we say if our challenge is to build the sewer and take the pollution out the river, our vision is one, and it's on our lanyards. We talk about reconnecting London with the River Thames. It's interesting. When I first joined the project, we were at the back end of the development consent order process, which was a very, it's a public consultation process. There was a lot of heat and a lot of opinions about what should happen. So the team that I joined was a team that had got very used to talking in technical terms, in terms of cubic meters or decibels or percentages of oxygen or whatever, and in a very legal way. But what I saw amongst the 300 people that I joined was that there was a huge passion and belief and enthusiasm for what we were doing, but we didn't really have the vocabulary to express that. So one of the first things I did when I joined was to set up an area on the 3rd floor of the office we had, put a picket fence around it, put some AstroTurf down and some weird chairs and tables and walls you could scribble on, and ask people to express their views and use that as a place where we called it our space, and it was a place where we could go and we could talk in a way that wasn't our normal way of talking. And you can imagine how people reacted to that. It was a company full of accountants and engineers and lawyers, and looking at this picket fence thinking, well, who the heck has just turned up? But it was a really fruitful exercise, because we took about 3 or 4 months to really sort of distill what we were thinking and what we were feeling, but didn't have the language for. And we did that through a whole series of workshops with our teams and with larger groups, and we boiled it down. We didn't use a brand consultant or anyone else to sort of help us with the catchphrase or whatever, but every time we tried to find a verb that we could use to describe what we're doing, it began, every word seemed to begin with RE. So we were either resuscitating the river, we were rejuvenating it, it was something to do with the Renaissance, we were repairing. And so that became a very clear theme, and we ended up with our view that what we think we're actually doing is reconnecting London and Londoners with the River Thames. And once we got that clear in our own minds, and again, what we didn't do is stick a set of words on the wall or a paragraph that we all had to learn parrot fashion so we could go out and say it. We all practice saying this in our own way. So using that basic theme, how would I as an individual describe this bigger story that we've got? And I think the net impact of that was profound. It worked very well for all of us, but it also helped in the way that we talked to everyone around us. In that it came from the heart because it was people's own words or a sentiment expressed in their own words. And I used to get a lot of feedback saying it doesn't matter who we talk to on Tideway, we get an overwhelming sense of passion and commitment and enthusiasm for what we're doing. And I think, yes, we're going to talk more about the engineering and the system and all that sort of thing, but I think it's really important as you're launching on building big infrastructure for society that you've got a really strong understanding of actually what is it you're doing. Yes, you're building a tunnel, but what's the societal benefit? What's the point? And why should we be allowed to spend or asked to spend taxpayers' money or bill payers' money? And I think it's really important as engineers that we understand that it's not sufficient just to talk about the technical. You've got to understand it's the whole harnessing the forces of nature for the benefit of humankind. And really, what does that mean? And I think for me, this is that translation between the technical and then why. And why should people want to support us and put up with us, to be honest. So it's a two-part story, which I'll touch on as we go through. So where does this all start? Well, those are the tributaries. If you go back 300 years, you'd have been able to see all these rivers around London. You can see very few of them now because most of them are now sewers. So the River Fleet, a big and recognisable point. It's why Fleet Street is called what it's called and all that sort of thing. And the Fleet River used to reach the Thames just where Blackfriars Road Bridge is. So if you can picture the Unilever building, which is on the north bank, just upstream of Blackfriars Bridge, it's got a curved shape to it. And that's because that was the shape of the bell mouth of the River Fleet as it joined the Thames. So that's how it looked. But of course, before we came along in any significant numbers, but as London became populated, we went from the process of throwing pounds of stuff out the window, which got to a point where that wasn't acceptable. So then cesspits were built, and that didn't really work either. The flushing water closet was invented, and that meant the volumes that had to be dealt with didn't work with a cesspit arrangement. And they were leaking. There were no standards or specifications, and other people's, your neighbour's basement was filling up with your business. So the legislation was brought in progressively such that all the sewage that was being generated was channeled to the nearest river, the nearest tributary, which was fine. It solved a problem at a point in time. But of course, what happened to those rivers? Well, they became sewers in their own right and were effectively culverted over. So the rivers became unrecognizable as a river. You still get the fluvial flows coming through some of them, but primarily now they're sewers. So that worked for a period of time until the population grew to about 2 million, when by which point the River Thames itself was really just one enormous sewer. And got to the point where, back in the 1850s and 60s, where tens of thousands of people were dying of cholera and typhoid There were lots of arguments about it was nothing to do with the water, it was the miasma, it was an airborne disease that was causing this illness, and eventually that was proven to be wrong, which really shouldn't have been rocket science because it was foul, it was stinking, and it was one particular summer in the late 1850s, I think, when the stench was so foul that Parliament was talking about moving to Oxford because it was just so unpleasant to be there. And as the story goes, and I've not heard anyone contradict it, the reason that we have such a long parliamentary summer recess because it was based on the summer that was really, really hot, where it was so foul they had an extended summer break, and that was a habit that stuck. It's funny, isn't it? So anyway, that got to a point where that was clearly unacceptable and something had to change. And it was the city's municipal engineer, Joseph Bazalgette, at the time, who was asked to do something about it. I think it's quite interesting that it's only when you really offend Parliament and the politicians that decisions get made. There's no parallels there today, obviously. So, what did he do? Well, he built these interceptor sewers north and south of the river to intercept the tributaries that had become sewers and channel all of that to the east of London and to now what we would recognise as Becton sewage treatment works. And his brief was a simple one, bearing in mind this is a very tidal river, that where the outfall, the northern outfall on the north of the Thames there, had to be located such that as this sewage entered into the river on a low tide, as the tide came in, obviously the sewage would get washed upriver. So it's located where it is, because even on the most extreme tides, the sewage couldn't get to Westminster anymore. And that was part of the spec for building the job. So that's why that bit's there. And that was very effective. And if you ever get a chance to go down the old Victorian sewers, which might sound a bit of an odd suggestion, but I really would recommend it because the quality of the workmanship there is just staggering. It's Bazalgette invented effectively the modern standard for OPC, ordinary Portland cement, because he saw such a variability of cement quality, and he knew this had to last a long time, so he set what was deemed to be an almost infeasibly high spec for the cement, but it is the basis of our modern spec for OPC, and it was achieved. So it's a work of art down there. They say the craftsmanship, the quality of the materials, it's amazing, and the system is doing exactly what it was designed to do, which is in normal times to protect the river and to take the sewage to the east. There were 2 million people when that was going on, and we think Sir Joe had probably 4 million in mind. So he was thinking about doubling the size of the city, which I guess is something that the Victorians excelled at in terms of being ambitious about what they did. But of course, there's nearly 9 million now, and we're talking about 10, 11, 12, depending on what report you read. So his system is doing exactly what it was designed to do. It's just overloaded. The Paviors have some of the blame for this, it's got to be said. There are 3 reasons why this is tougher now than it ever was. One is the population increase. The second is that more and more of the land has been paved over, either with roads or concrete or whatever. So we're on London clay anyway, which isn't a massively helpful material to absorb rainwater, but nonetheless, the more hard standing and paving has contributed to the volume of rainwater that ends up in the sewers. And of course, we're seeing much more extreme weather conditions now, and I know that's perhaps a more relatively recent thing. A few years ago, 4 years ago when I started all of this, I did a tour of sewer systems around the world, living the dream as you do, and I was in Chicago and I was talking to the people. London's about the 40th city in the world to have done this kind of scheme. So talking to them about what they were doing, and same story, same set of issues. And And they said, well, you know, a 100-year storm, a fairly sort of recognizable design parameter to use when you're sizing systems like this. And they said, look, we've had 3 100-year storms in the past 5 years. I don't even know what a 100-year storm is anymore. And undoubtedly, that's all part of our issue. So Joe's system's doing exactly what it was designed to do. When it gets full, the sewage has got to go somewhere, and it either goes back in the streets or it goes into the river. So that's what it's doing. It's working perfectly. So what are we doing? Well, we're building the existing sewer system will continue to serve London. All we're doing is supplementing that and effectively capturing what comes out of the spill points into the river, capturing that, putting it in our tunnel, taking it out to East London again and taking it to Becton sewage treatment works. It's a large tunnel, larger diameter than the Crossrail tunnels. It's 25 kilometres long. And if you do the maths, that takes you to 1.6 million cubic metres, which is important. Because it's a reservoir as well as a pipe. It's what they call a transfer and storage scheme. Because Becton although Becton's been upgraded by about 40% over the past sort of 5 years, and Thames Water think it's probably the largest sewage treatment works in Northern Europe, but it still can't keep up with what's going on, let alone all the stuff that we're bringing to it. So our tunnel sits dry when it's not raining, and it's there, therefore, as an empty tank. So when Bazalget's system gets full and the spills happen, we capture those spills and we take them into our tunnel. The chances are it'll sit there because Becton can't handle it. And we can take a day and a half of pretty heavy rain across all of London. And eventually, when that stops raining, then the big pumps kick in at the far end and can then pump our tunnel dry. That goes through the sewage treatment works, and then our tunnel sits dry for the next time when it rains again. So that's sort of how it works. Now, of course, our tunnel can fill up too. So we think rather than the 60 times a year that happens at the moment, we think our tunnel will fill up 2 or 3 times a year. So we're reducing the volume of spills into the river by about 95, 96%. But we're reducing the volume of sewage that goes into the river by about 98, 99%. And as importantly, at the moment, if it doesn't rain for some weeks, then what's in the sewers is sewage, undiluted sewage, if you like. And it's that first downpour of rain that inundates the sewer, nowhere for it to go, and it's that first flush of sewage that ends up being put into the river, and hence the sort of the videos that we saw earlier. But we capture that. Now, by the time our tunnel is full, it has been lashing down in London for some time. So what is then in the sewers is way more diluted with rainwater than the pure sewage that first comes out. So when we fill up, we've got to do exactly what Sir Joe's system does, which is spill back into the river, but way more diluted, so way less impact on the river, and way less frequently. So as it stands at the moment, what we understand to be likely anticipatable weather, if we were to have sized this system to effectively take out the tail of the storms the last 2 or 3 times a year, we'd have had to have more than doubled the size of the tunnel. And therefore damn near quadrupled the volume of materials and the cost and all the rest of it. And again, talking to people around the world, they seem to have come to the same conclusion that 2 or 3 times a year is probably the point at which that you've reached a point where it wouldn't be easy to justify further spend. But I think this is where we need to get to the SUDS piece. I think very, very unhelpfully during the DCO process, there were people saying, no, this SUDS should be used to do this and we shouldn't be spending all this money on a big piece of infrastructure. Well, I understand, but if you consider the 1.6 million cube, so whatever you're going to do with SUDS has to accommodate 1.6 million cubes. So if you're going to, all the sort of various SUD schemes of porous asphalt, or whether it's drainage layers underneath the roads or whatever, you've got to create 1.6 million cubic meters of it, which means digging up so many roads, and you can't dig up a square meter of road without finding pipes and wires and God knows what, and it's really not feasible. But I think very unhelpfully, because some people were saying SUDS is the answer, and then of course the promoters of the scheme were saying, no, the tunnel's the answer. It became a very binary argument, and it never should have been a binary argument. It should have been, we've got to do both of these. The only way we're going to address the issue that we're facing in any sensible timescale is to build this tunnel. But if some of the people in this room, the younger people in this room, aren't to be getting involved in building another one of these, well, probably not in this room, but in 60, 70, 80 years' time, we've got to do something more intelligent about the rainwater. It is just madness, if you think of it, to take perfectly good rainwater, to mix it in with the sewage, to a huge amount of money to get it somewhere, then to put a huge amount of money into processing it to get the water out again. It's illogical. It's not how you design a city from scratch, but it is the way it is. So for me, as planners of London and other cities go forward, we've got to get way more clear and way more strict on what we do with rainwater. And I can well imagine in 30, 40 years' time, I've heard it said that around the world we won't be having wars about petrochemicals anymore, we'll be having wars about rain and water. And I hope, therefore, that people in future think about water in a different way, such that it would just be unthinkable to mix it in with sewage. It's what we've got to do. We've got to get way smarter. So new developments, whether they be residential or business office or whatever, schemes in future have to address this issue. It's going to take decades to sort out because, 90, as we say in the general construction industry, we worry about the 1% of a built environment that we build every year, but it's the other 99% that you've really got to get at. So there's a lot of work to do to make sure that we're not having another tunnel debate in decades to come. That makes sense? Are you convinced? Not that it really matters, to be honest, because we're building it. So, but it is a really important issue, and I hope one that we've learned something from. Perhaps the other thing to say off this slide is that this is a self-cleansing tunnel, so it falls at approximately twice the rate of a normal sewer. And that's such that, so let's say our tunnel's full and there's nothing flowing anywhere, you will get some settlement along the base of the tunnel. But the next, and then it empties as the pumps kick in, but the next influx of rain, of sewage, will then be strong enough such that it cleanses itself. So it's a self-cleaning system because of the rate of fall. So it runs from Acton in the west, square number 1, gets to the river as quickly as we can. Interestingly, passes within about 50 metres of the south abutment of Hammersmith Bridge, which is causing a few interesting conversations at the moment. But we will be underneath, we'll have gone past in about 3 weeks' time, and then we'll be okay. We find the river. We follow the line of the river, ostensibly down the centre of the river, but we do zigzag a little bit from bank to bank because the spill points are on both north and south bank. Every one of the circles, the coloured circles, is an interception point where we capture and lower down and feed to the main tunnel. Passes all the way through central London. We get beyond Tower Bridge. We get to Wapping, and then we cut across country to Bazalgette's Cathedral of Sewage, Abbey Mills pumping station. Again, if you ever fancy going to a sewage pumping station, that's the station to go to. It is an architectural marvel. It's an industrial pump house. Why it looks the way it looks, I think we understand, because with all the work that Bazalgette was doing, what he knew, and we get this, is that nobody would ever see it again. And he had nothing to show for his efforts, so he threw the kitchen sink, if I can misuse my analogies, he threw the kitchen sink at Abbey Mills, so it's got architecture from different centuries and from different parts of the world, and it's a really, really impressive piece, but it was the only thing that anyone was ever going to see again. So we get down to there, and we meet the lead tunnel, which was built and commissioned a few years ago. So that's typically what we're building at each of these circular sites. That is a cross-section through our Victoria, site. So you see the embankment, and of course, it was Bazalgette that built the embankment. That wasn't there before he started. And you can see the right next to the river wall, you can see that the top arch piece is a service corridor, and then the piece below is the sewer, the interceptor sewer that he built. Just a little bit further inland, and this is where you've got to admire the Victorians. While he was at it, and I think just because he could, he built the world's first underground railway, which was the Metropolitan and City line at the time. It's now the District and Circle line. As I say, you've got to admire the Victorians for doing that, but that was all part of what was done then. So what do? So we capture that sewage, we channel it to our drop shaft, and with a small connection tunnel, we go and join the main tunnel. Now, there's a couple of interesting points in that drop shaft. The first is that you'll notice that the sewage is actually channeled down what we call a vortex generator. So it's fed into the side of the vortex generator, so it spirals its way down. Because at Blackfriars, where the Fleet sewer comes in, when that's going full pelt, that's 30 tons a second coming out of the river wall and into the Thames. Now, so we've got 30 tons a second, but we've then got to drop it 50 meters down a drop shaft. There's a huge amount of energy and force going on there. So therefore, what happens is you spin that around, you try and lose some of that energy. In doing it, obviously you're entraining air as part of the vortex, which you've then got to get the air out at the bottom, which is what those two settlement pits are, so that ultimately what goes into the sewer is as much water as possible and as little air as possible. If you go to YouTube and you look up sewer geyser or sewer geyser, you can see what can go wrong if you don't get this part of the design right. So imagine, so you've got all this volumes of liquid coming in, but then of course the tube's full of air, the tunnel's full of air, so the air's got to get out somewhere. So it's rushing around, and you get huge transients that work up and down like a sort of water hammer type effect, but on a really big scale. And that air's got to get out somewhere. So if you imagine our main sewer pipe there, and you imagine a small straw just sticking out from the top of that and finding the atmosphere, and you've got a huge amount of water sloshing around, and you've got air trying to get out. What's the air going to do when it finds a straw? It's going to whistle up the straw and shoot out the top. So these sewer geysers, that you can see where cars are perched on a fountain sort of 3 or 4 meters high of sewage, is what happens when the air escape is a smaller diameter than the vessel that it was sat in. So the other reason, so we've got this small drop vortex piece, but then you've got a way bigger area for the air to rush into and slow down so that it doesn't try and whistle up in the air and bring sewage with it. So there's logic in what looks like a slightly disproportioned scheme. We've broken the works up into 3 separate areas. For commercial, practical reasons, we didn't want all of the eggs in one contracting basket, but it lended itself to following the geology. So in the west, the shallower, so we start at about 30 meters deep and we fall to 66 meters deep at Abbey Mills. In the west, it's the London clays. So that first section, that first contract is tunneling almost totally in clay. You get below the London clays and you're into the mixed sands and gravels and the various beds that you've got there. And again, a different type of tunneling and a different type of tunneling machine. And then you get below there again in the east where you're deeper still and you're into the chalk, which sounds really nice, but when we say chalk, it's actually got flint boulders in that are massive, and it's quite a challenging, it's very porous. With these big boulders in, strong stone, and that takes a different sort of treatment. So we've got different tunneling machines for the different areas broken up in a geologically logical way. So where do we fit with the other tunnels in London? Well, we started at about the depth of the deeper tube tunnels. And you've got various other services running through there, the power tunnels and whatever. But so we fall all the way through London, and then the lowest black line is the lead tunnel, the deepest tunnel built in London, which goes further down again because it's best part of 78 metres deep by the time it gets to Becton sewage treatment works. What it does mean for us is that we're a long way away from most other tunnels or structures, and of course we're under the river anyway when there's no buildings above us. So in a lot of ways, and in many ways, it's a lot easier tunneling than we had on Crossrail. We don't have listed buildings above us. We're not, we're a lot further away. We're not just below the buildings from a settlement point of view. We're way below the piles either. We don't have to worry about eating through some of the piles, which is what we had to do on Crossrail. So it works like that. And actually, once you've got into the tunneling, it's a relatively straightforward process. The materials are challenging, but at least we're in control and we don't have some of these externalities that can be challenging. When we talk about the other side of the story, the emotional side and the legacy and what it is we believe we're doing, we talk about it under these 5 headings. Now, obviously, environmentally, the impact of removing the sewage is clear. Incidentally, and I'll talk a little bit about the funding later, but I got the whole board, shareholders, chairman, the lot out on the foreshore at Fulham last summer, where we were doing what was euphemistically called a wet wipe survey. So you take a metre square and you plonk it down on the foreshore and you have a little spoon type thing and you see how many wet wipes you can pick out of a square metre of the river. But of course it's not wet wipes, it's all the other things that people put into sewers. It's amazing, but that's how it is. And typically we were counting 200 to 300 items per square metre in the top 2 inches of the foreshore mud. So, which of course will stop once we've done our bit. But London does have a question to answer, which is, well, that's fine, we're not adding to it anymore, but really somewhere along the line we need a scheme that goes back and takes all that away. It's just not necessary. And I try not to be a river nerd, but sometimes when I see people on the foreshore with their kids running around, I'm thinking, oh my goodness. On the one hand, it's important that people commune with nature, but it's also important to understand what you're communing with exactly. And so we have to work on that. But our environmental impact is an obvious one. Health, safety, and well-being, again, is another issue. Having worked on many, many big projects, I wanted to see us take a very different approach to how we look after ourselves and how we look after our neighbours. And we've redesigned how that piece works. We have an induction process that takes several days before you can get anywhere near one of our sites. We have a full 1-day induction, which is an interactive actor-based thing where we talk a lot about the things that we normally do and why do we do them and how could we think and behave in a different way. And nothing's ever perfect, but what we are doing, these actors turn up on site and sort of rework some of the things that we did in that induction day, and it's a narrative. It's a 1-day thing, but it's the start of a story and it's the start of a discussion that we keep going through the life of the works, and it is making a difference, and I'll touch on that a little bit later on. So the economy piece, well, we believe that as we were creating the 8 new pieces of land that we had to build out into the river, that we were probably running at that point the largest civil engineering fleet that the river has ever seen, and it needed a lot more marine workers, people operating the tugs. So we worked with the Port of London Authority to set up the Thames Skills Academy, which was a place to bring in new apprentices, and some of those are now working on the river, and that's all part of the story. But of course, what we are proving at the moment is that you can run a 24/7 mission-critical logistics operation on the river. Now, if you can do that for what we're doing with high expenses if it's not successful and you have to stop operations, then what else could London do with that capability? Why aren't we talking about all of the deliveries into central London coming by river, getting to the nearest point and then doing the last mile, mile and a half to wherever that's got to go? Because that last mile and a half is then an electric mile. And you've got a totally different picture of how materials are moved around London. You've got this thumping great motorway running through the middle of London, and we don't really use it. And I think there's huge opportunities. And we do know that some of the large distribution companies are having discussions now about, so what's their application of this, and I really hope that's the case. The people piece. These days, whether that's internally and whether that's I don't think we're, to be honest, particularly different to a lot of other big projects. We have 1 in 50, a requirement that 1 in 50 people working on the job are apprentices, 1 in 100 are ex-offenders. 25% of the people working on the big sites are from the local borough, and we've managed to achieve all of those, which was a challenge. We do a huge amount of volunteering. We actually set ourselves targets for the amount of volunteering that we'd like to see all the people, everyone working on site as well would do. And every time we set them, we beat them. Last year, we beat our targets by about 5 times. And I think we've got to a point now where we don't need to promote volunteering anymore. People just want to do it because that's kind of that's part of the project and how we are. And then the place piece I'd like to talk about later. You don't often get a chance to create new London. You can knock stuff down and build something else, but you don't often get a chance to create a new piece of acreage. So we'll have a look at that. But let's take the transportation story. If all the material went by road, there'd be just over 500,000 vehicles. So that's a million journeys, a 1 in and a 1 out. We had obligations under the planning permission, under the development consent order to reduce that by some 50%. And the contractors, when they bid, reduced it naturally more. And we said, well, that's fine, but having awarded the contracts, now what can we do to use the river even more? And we went further again to take that down to an over 70% reduction. So all of our excavated material in the shafts and the tunnels comes out by river. All of our tunnel segments come in by river. It makes a huge amount more. You don't get traffic jams out there, and it only gets fogged off maybe 1 day every 2 years. So it's a way more sensible way of shipping stuff anyway. So let's have a look at our very own Terry Wogan, James Carew, who put this piece together.
Rivers, the lifeblood of cities across the globe. It's the reason they're located here in the first place. People use them for transport, for trade, even for food. Then in the 19th and the 20th centuries, it became about roads, railways, eventually the skies. But the rivers are making a comeback. You might know the Tideway is building a super-sewer deep beneath the Thames. It's a 25-kilometre long tunnel going from West London all the way to East. But did you also know that they're using the river on a scale we've never seen before? So Nargis, what's happening here at Carmel Road?
So Conworth Road is the main drive site for the west section of Tideway, and our tunnel boring machine is going all the way from Fulham to Acton.
And how are you using the river?
So the excavated material from the tunnel is getting brought up on a conveyor belt, which is then loaded onto barges at our site.
So you're taking all this material and putting it on barges instead of lorries?
Yeah, exactly.
Ed, what are we looking at behind us?
A barge changeover between a light empty barge and a loaded 1,500-ton barge full of muck.
Typically, how many trucks would one barge take off the road?
We argue that one barge movement of a 1,000-ton barge can take up to 50 lorry movements off the road in one big hit.
Using the river instead of roads is good news for cyclists and pedestrians. In fact, at its peak, Tideway is keeping up to 200 lorries off London streets every single day. And this has other benefits for the environment too. Compared to lorries, barges produce 90% less carbon dioxide and 86% less nitrogen dioxide. That's a breath of fresh air. All of this makes using the river a no-brainer. The Thames is bustling once more. busier than it's been for centuries. So while the super-sewer is bringing the river back to life, it's also bringing life back to the river.
So that was our, I've got to wait and listen to the seagulls, sorry. So that was our Every Boat Counts campaign, which, yes, of course, that's about us waving the flag and saying, aren't we doing a good job? But what we're really trying to do is say, we need to think about this river in a different way. We need to think about what this river can bring to us. And for sure, if you talk to the company of Lighterman and Waterman, which is a 400-year-old company, the Lighterman were the barge operators. They were the people that rode the cargo, and the Watermen were the taxi drivers of the day. And really, we should be thinking of the river in that way more and more. What James was saying there, we didn't have any data when we started, so we strapped a whole bunch of monitors onto the barges that we were using, and these sort of statistics come out. 95% less carbon monoxide, 90% less carbon dioxide, 86% less NO2 and the particulates piece. And of course, you're out in the middle of the river, so it gets dispersed much more quickly and is therefore less impactful on people. So these are all thumping good reasons why we should think of the river in a different way. So part of the piece that obviously we do, and again, I don't think we're any different to any other large project, is how we engage, and we start with the schools and the whole STEM piece, the tree planting, working with the communities and helping people understand the opportunities, working in construction. We've been at Pride for the last 3 years. I think this will be the 4th year this year. And it's important that we understand how to maintain the support of our stakeholders with a capital S, if that's how you say it. Princess Anne very kindly did take up the offer of going down a sewer and having a look. So my comms team, we were on watching an event on the river, and Princess Anne joined us for a short while, and someone in my comms team said, ask her if she wants to go down. And I thought they said go down the sewer. What they said was go and have a look at one of our sites and go on a new tunnelling machine. I invited her down a sewer, and she said, yes, I'd love to. Bless her. And she was thrilled. She genuinely was. That was indeed my board on the cleaning up of the foreshore thing. A lot of the river charities were very supportive of the project in the first instance, and we continue to work with them. So Thames 21 and London Youth Rowing, who put a lot of effort into getting people to work with and appreciate the river and what it could be for us. It is important, as I was saying at the beginning, to make sure that you understand the impact that you're having on the communities within which you work, and the communities that basically have to put up with you while you're working. And these are the results from our latest surveys. And yes, they're incredibly positive. That's taken a lot of hard work to try and get our story understood. And I think we can all picture large infrastructure projects where who would give an awful lot of money to be in a position where people are talking that way about the project. It's part of the job. It's not an optional thing. You have to get this piece right if you want to be successful in building infrastructure where people live. And we're massively... See, we're the only office I know where you have pictures of boys and girls sitting on toilets. Seems natural to us these days. But again, an awful lot of effort trying to put our story out. All the videos that we produce, yes, we do it for ourselves because we like communicating internally about what we're doing, but all of the videos that we create, the monthly time lapses, we put them all on the website, and we encourage people to have a look. And I spent a long time building our social media footprint. So the lasting legacy piece, so the land that we build out, so in a couple of cases when we build out into the river, we've got to take it all away again when we finish, but in a lot of cases, the shafts that we're building will be within the land that we leave behind, so that's what we're leaving behind at Putney. This will be one of the first sites to finish, so I'm hoping for the boat race in 2021, that's what that piece of Putney is going to look like. That line that you can see coming off that fender there is the start of the Oxford-Cambridge boat race. It's written into the development consent order that once a year we have to remove anything that's in the way of the sight line of the start because someone needs to blow a whistle. But we'll be leaving that piece behind. The twisted chimney that you see is a vent column, so it's the exhaust of one of the air outlets. And there's a whole scrubbing system, carbon filters and all that sort of stuff so that the air doesn't smell. But we've put a lot of thought into what we leave behind, and every single one of these, and you'll see it when we've put them in place, but that spiral spine, every single one of those has got a short poem, almost like a haiku, which is relevant to the area and tells a little bit of a story about the history of the area. Now, is anyone ever going to see that or understand what the heck we're on about? I don't know, but I think there's a lot of thought has gone into what we leave behind and why that should mean, could mean things to people. So that's Chelsea Embankment where the flower show is, obviously the Chelsea Hospital behind it there, and again trying to reflect part of the London infrastructure that's already existing in a different way. These are floodable public realm spaces, so where the reeds are is an area that the public can get into. Gave some people the heebie-jeebies that we were encouraging people to get into a floodable space where you can get hit by the wash of boats going by, but thing we keep saying, coming from Cornwall, yeah, the beaches flood every day, but we don't fence them off. We just help people understand how to be on a beach and do it safely, and it's all part of getting back and closer to the nature that is running through our city. And I think another really important point. That's Albert Embankment. You can see the circle. Guess what's under there? That are our most immediate and certainly most sensitive neighbours. That's MI6 behind us. I think it's fascinating. Only in this country could this happen. You Google that part of London, and it simply says Secret Security Services, which is cool. I guess if you needed to know, you'd probably know that was MI6, but there you go. Another piece of new land at Albert. And again, that cross-section that I showed at Victoria, that's the piece we're leaving behind there. What a cool place to watch the fireworks. It's right opposite the wheel. I'm still trying to figure out how I get the franchise for selling tickets there once a year. But, and then you've got Blackfriars, our single largest space. The spill point, as this new piece of land tapers in, that's where that spill point of the Fleet sewer is. And we have a channel that runs from the bridge therefore all the way to the widest part of this piece of land, which is where the drop shaft is. And that's the space we're leaving behind. It's about 1.5 acres of new London. That was the proposal. You can see the vent columns again, and that was the proposal at the time of planning permission. That's what it now looks like to us. Again, a huge amount of effort gone into there. It's a natural meeting place for people. It's where, in future, the clipper services that go upriver and downriver will meet at the Blackfriars Pier. It's where the cycle superhighways cross, and it's where there's an awful lot of, the Blackfriars railway station, another piece of form I've got, meets the tubes and whatever. So it's a natural meeting point. So every single one of our sites, we've commissioned an artist come architect to help us understand what should we be leaving behind. It's quite daunting. It's easy to come up with something that's really cool and of the moment, but what we'd hate to think is that in 10 years' time, people look at it and think, what were they on? So this is where we are. The artist is a chap called Nathan Coley, and his concept with this sort of people meeting in mind with these black pieces, which he calls the black stages, where he talks about a space within a space. And this is a place where you could imagine meeting someone for an occasion or whatever. And I like it. They're quite big. These things are 5 meters high. They're not, but it's a big space. You could argue, is that a bit brutal? I don't think it is. I think it's in context with the space that we're creating. But as I say, here's a civil engineer talking in a quite a different way about what we're doing. But I think it's really, really important if we're really to achieve the effect we want. So that's called Blackfriars Embankment, except it's not, because we got it renamed Bazalgette Embankment, which is just marvellous. Yeah, genuinely, that's what it's going to be called. So you'll see a sign with that on it in some years to come. Latest progress. So we started tunnelling in 18. We're in the middle of tunnelling now. By early next week, we will have completed 12.5 kilometres of the main 25-kilometre tunnel. So we're halfway there on the main tunnelling, and we're going full pelt. We'll finish tunnelling back end of 21. By the end of 22 into 23, we'll start the testing and commissioning, and we should be all done by 2024, at which point I pack up and let someone else have a go. Shafts, we've got 23 shafts. We're working on all of them. We've now completing the secondary lining, because everything we do has got to the primary lining, which is the structural one that allowed us to build it, and then there's a secondary lining, and that goes for the main tunnel and the shafts as well. Because if you think of it, you're 70 meters deep, you've got potentially 8 atmospheres of sewage trying to get out into the aquifer, and equally if the tunnel was empty and the aquifer is high, you've got a similar amount of atmospheres trying to get into the sewer, and neither of which is a good idea. So everything's secondarily lined. We've built most of them. We've only got 2 shafts that are still in the primary lining stage. Most of them are formed. And from a civil engineering point of view, the point at which you can get the big base plug in is a really exciting point, because at that point you've stabilized the excavation, and what you do thereafter, again, is much more under your control. So that's kind of fun. So typically, therefore, what you now see is one of our sites, this one, the Chelsea one, which great big rectangular cofferdam, but you can see the shaft, you can see the bit next door, which is the interception chamber on the right-hand side, which is what all of our sites have. So they're all broadly in that kind of shape. Kirtling Street, that's our double drive site. So we have a TBM goes west and a TBM goes right, and that's within the grey shed there. All of our tunnelling is done within an acoustic shed so that we can tunnel 24/7 and not disturb the neighbours. And that's Battersea Power Station next door. Blackfriars, so explained all that, but interestingly, and I do say to the engineers working on this, you have no idea how lucky you are. The tail end, you see on the photograph on the top left corner, there's a floating barge which is sort of stuck into closer to the river wall. And that's where ultimately we've got to have the culvert that captures what comes out the river wall and takes it to the shaft. But it's really difficult to build in that position. So what you see on the right-hand side is a dry dock that we're building. So that piece of the culvert, and you can see the sort of scale of it, we're going to build in the dry dock, and we're going to cap it, flood the cofferdam, float it on a single tide, and once only move it into position and let it sink on the tide, and then that's in place. It's up against the river wall. That's that bit done. Then we'll close that cofferdam again, and then we'll go and build the in situ bit and mate up to it, and what could possibly go wrong? That should be happening in about June time. So if you keep an eye on the website, you'll be able to go and see that. Knowing the team, they'll do it at night because no one likes people watching them when they're doing things like that. But if you're really keen, you will be able to see that happen later on this year. And again, that's a slightly more detailed picture of it from just a few weeks ago. So yes, tunnelling. Main Tunnel A is working its way, about to pass Hammersmith Bridge. Main Tunnel B is finished at 4.9 kilometres. A Main Tunnel C, which has left Battersea and is now actually at Blackfriars, where that location, having its teeth repaired before it takes its last piece of the journey off down to Southwark. Going well. This is something that we didn't do on Crossrail, which is put a live map of where our tunnelling machines are, for fear of people claiming that was the day their windows cracked. but we don't have people above us, so we can be a little bit more open about where our machines are. I won't click it, but if you want to have a look at that, you can see where the machines are on any day of the week. Chambers Wharf down in Southwark, again, same idea. Those are actually the prefab rebar cages for the base slab pour. So that was taken a little while ago, and that's our acoustic shed again. What you see on the right is the slip form preparations for the slip forming for the secondary lining. That has actually now finished last week. Greenwich, so again, you can see the shed. That's where the shaft and the tunnelling is being done from. Right next door to the Docklands Light Railway, which is right next door to the Network Rail system. And you can imagine how nervous and excited some of those conversations were about you're going to do what next to us. That's Annie, the TBM that will ultimately end up going down that shaft. A few more bits. Yes, there's another TBM. The photo on the left is interesting. That is how we've treated, because if you imagine, we're intercepting and therefore building right next to the existing sewer network. So that is a temporary flume which is passing straight through our works which we're building. That is a live sewer. We've channeled the system through that. We'll build the whole intersection chamber around it, and the last thing we do is basically take that pipe out, and then our system is live at that point. Recent favourites, nearly there. So secondary lining, as I said, that's the main tunnel A, the one that's heading off towards Hammersmith. That's the secondary lining, one of the secondary lining shutters that's part of that process. TBMs are typically 120 metres long. This secondary lining set up to allow us to pour 300 cubic metres of concrete every day on a stitch hit and miss. So you pour those and then you shunt up and you pour those and you work your way up the line doing that. That whole train that allows you to do that is something like 240 metres long. It's a big piece of process and a big piece of kit, and that's just kind of cool. That's just a piece of embedment, but the reason why that's exciting is that these are the first pieces of the operating sewer now being prepared against the formwork and now starting to be cast in. So we're starting to get through just the pure civils phase, the pure concrete phase, and we're now getting into the start of the mechanical phase. Exciting for some of us. Most of what we do is underground, so that's really cool, because a couple of weeks ago we poured our first ground slab. So that's at Acton, and that's the interception chamber underneath. So again, it's a small piece of civil engineering, but big step. That's just one of the bases of the shafts. It's quite photogenic, which is why I put it in, really. Kind of cool. Now that, so the main tunnel's gone up the river. That's halfway, that's under the river, in the middle of the river, and that is the main TBM segments that you can see. But of course, we've got connection tunnel that comes from the shaft to go and find the tunnel. So that is the outside of a TBM tunnel, about 30 metres below the River Thames. Fortunately, both tunnels were in the right place, so we got that bit right. And of course, when we're ready, what we'll be doing is breaking through that wall and then joining up the connection tunnel with the main tunnel. But you don't often get to see that. I like this because that's a pipe jack machine at Putney, which came out. You might have known Putney Bridge was closed on the 2nd of February. That was us to allow us to do this. And it kind of fits nicely, very photogenically with the double-decker bus, and eventually got landed next to the church. Boy, we've come a long way in site briefings. The construction industry is moving on. It's not the world that perhaps it was when I first joined it. That's not for show. This is a start a shift briefing with a difference, and it's not uncommon. Talked about well-being earlier. We have a thing called mental health first aiders. So it's a 2-day course that any of us can go on. I'm a mental first aider. There's 170 of them on the project. We have nearly as many mental health first aiders as we do physical first aiders. And when we first put the thing out on the notice board saying, is anyone interested in mental health and learning more about this and how we might be helpful to each other, we were inundated. And I'll be honest, I was thinking this is a bunch of men and we're crap at talking and no one's ever going to want to do this, but we were inundated with people from every level of the organisation saying, yes, I want to know more about this. And it's all part of building a culture that's way more inclusive and way more caring and way more thoughtful in general. And so it's, in that context, it's not so surprising to see this, although I don't think you'd have seen that even five years ago, which is why that one was there. I do have another video, but I think I've said everything and it's probably banged up. Shut up. So, oh God, I'm going to have to apologise for that now when I get back to work tomorrow. Sorry. So as I say, there's an engineering story, but there's also a way, way bigger human story, and whether that's how we relate to it and what it means to us, or whether that's how we tell the story of the benefit of what we're doing to the public, they're equally important, and these are really two important aspects of building stuff for society going forward to the younger members of the audience. That's really all I had to say. I'm sure there'll be some questions, so thank you very much for listening to me droning on, and we'll go from here. Thank you.